So next thing we're going to be looking at is something called group by. What group by does is allow us to come on, zoom in. Is say, well, take all the things that looks like each other and consider them the same. Which, if you just listen to what I said, is confusing. But see, for example, over here with user ID, we have some of them appearing again. So like we have user ID 1, user ID 1, user ID 1. Well, what if we wanted to figure out how many tasks each user had? So not which tasks. Like we can go figure out, alright, so select from task where user ID is equal to 1. Then we'll get all the tasks that user ID 1 have. And then I want to do it for 2. Alright. And that's all for 2, and then 3, and that's gonna be executing a lot of queries, right? I just wanted to figure out how many tasks they had. I did not care about their tasks, so I need to figure out how many tasks they have because I need to give them more tasks. And I should be less evil and only give it to the guy with the least tasks. Of course. So, because if they already have a lot of tasks, they're not going to be able to do my task too. So I need to figure out how many they have. So for that, I can do a group by, and then say, all right, group by the user ID. And I actually don't think we can do this. We can technically. This is again my SQL being weird, because you should not be able to do a star query on that. Because technically, the only thing that we should be able to do right now is get the user ID. Now we just, all right. That's fun. Excellent, perfect. That was how many we had with the user ID. Now what, Mr.
Sorted by user ID.
Yeah. I think that's.
No,
it's not.
You selected the user ID column.
Yes, but it doesn't have to actually sort by it. It's just what it just happened to do. Because again, we were not explicit, so it would not have to do it. It could have sort them in any order it wanted. It did not have to sort them. Yeah. What we can also do is what we can do, like a group by itself is pretty damn boring. We're like, okay, awesome. You can tell me all the user IDs that exist in tasks. So what? Yeah. What we can do with them that is really, really powerful is what we call aggregate functions. So we can say, all right, give me, for example, how many we have. So give me the count of these things. And this is where I get the syntax, especially between databases, can be really, really confusing. Because some of them require something in here. So as you just saw, if I selected this, and remove space there, I get each user ID once. But then I tell it to count each user ID. I was like, what? And then I actually get out, all right, user ID 1 is there 3 times, user ID 2 is there 3 times, 3 is there 4 times, 6 is there 5 times. And then, all right, if I want to order by this thing, I can't really order by parentheses count user ID. Well, I think I might be able to. That, again, depends on the database. We can give it another name by doing as, and just call it C. So order by count, or well, C. And then it actually becomes sorted by how many we have. So I can say, all right, user ID 10, you have the least amount of work to do. Here's another 100 tasks. Get moving. Which is clearly unfair. You can also do averages, max. How you use these aggregate functions is really situational. But what they really take is like they take something to work on. For example, the user ID. I'm not sure what happens if I actually do max. Okay, then it'll get me the max user ID for that. But all right, what if I give I want the biggest ID that user is working on. I can also get actually I think I can get the max created. And then I can get the newest task that user is working on. Sorted again by that. So I tell, alright, they're working on a task that's that new. I can go for the...
What does the as?
That says take this column and give it a new name. So call it C instead.
Yeah.
Because like it's gonna be annoying to type this every time. I need to use that. And also when we get to, but that's like, I think the first part of the Node course is where we're going to be actually working with database from something else. Right now we're just literally going to be looking at doing SQL. I'm not actually sure if we can do average on dates, like I would imagine, but you never know.
That makes sense.
Well, I mean,
Because you make them the date.
yeah, and then the dates are underneath actually stored as numbers. So just whole numbers. It's not actually stored as this year, this month, this day. They're just storing, usually they're just storing how many milliseconds since the 1st of January 1970. Which is a very odd date. But that's what they picked. That's what they're going with. So if it's before that, it's negative, what they're storing. And yeah, then how many since then? So you can technically take...
Count the millisecond or the second?
That depends on the system. Again, some of them, they count nanoseconds. So that's like way smaller than milliseconds.
Yeah.
And other systems only count seconds. If you've heard of the thing called Unix time, that is just counted in seconds.
That's what I remember.
So like it also again depends on how much precision do you need. If you just need to know which day are we shipping this thing, I mean seconds are more than fine.
Yeah.
But
If you need to know exactly when someone did a banking transaction, people like having that at much more precise. Then if you're doing what is called high-speed trading, which is where they're trading stocks and much details we can go into on that on a later time, they are working at the millisecond or even less most of the time. So in that case, they want to have that with them.
like an auction on eBay also, it's probably less than 10 milliseconds, maybe.
Yeah, again, it really depends on what you need. Another thing you might want to consider is time zones. So put that in there because like just a given time and then saying from 1970, 1st of January at 00, like that's going to be 2 different times of day if you're in the US or if you're in Denmark. So then you need to consider the time zone too. What people usually just say is we do this thing called UTC time and just say in time zone 0. Then we don't need to save a time zone. Because then we can always, if we say that this date is stored as it would have been in time zone 0, which is England, well, we know how long we are away from England. So we can just add 2 hours and then we have it in Danish time. Or 1 hour, depending on if it's summer or winter time. There are all sorts of different tricks. Sometimes it is important to know what was the time in that time zone. If you're looking at someone doing something to a system you didn't want, it might be important to know that they do this during normal working hours or was it out of working hours, because if we need to fix it, it's more expensive to fix out of working hours because we need to pull engineers in and they need to get paid more. So then you need to store the time zone because then it actually matters what time zone we're doing these things in. So like just try matching the Outlook calendar when you schedule an event where you need to chat with someone in Asia, someone in Europe and someone in the US. And you in your calendar just pick 1 o'clock. But it should not say 1 o'clock to the guy in the US. It should be like 7 in the morning for him. And for the people in Asia, it should be like 8 in the afternoon.
Yeah, I noticed that, for example, I have appointments, for example, in Estonia. When I set the appointment in Estonia, I came back to Denmark, it's given me at 9 o'clock. But which is 8 o'clock there.
Yes, because that's what you specified there, and they save it with time. I think they just save it in UTC 0. because they just, well, this is at the absolute time in the universe that this is going to happen. But if you're saying things like, when is the sun going to rise? Well, that clearly depends on where you are on Earth.
Yeah.
And it's going to be, time zones are going to be really, really fun once we become an interplanetary species.
Yeah.
Like imagine doing time zones on moons and Mars. And with Earth, it's just going to be like, no.
Yeah, they're like about 6 months ahead, maybe, or behind.
Like it just takes 6 months to communicate with them.
Yeah.
Like, because in absolute times, we can still talk. We can still agree on and say on the whole intergalactic scale, we're going to be meeting at exactly this time, and we can agree on that. But if I'm going to say the sun is rising at 8, that's clearly my local time. Like that data is completely, can't be used for anything on Mars. Because like they might have 48-hour days, for all that matters.
Yeah.
So yay, again, another discussion. So aggregate functions. To be honest, I haven't seen them used much.
The what?
Aggregate functions. You use them if you're trying to analyze data. But most people just pull things into Python or something and then do it there, because it's much more reasonable to work with. It's kind of difficult to figure out how you should structure a SQL query once it becomes advanced. And it can become really difficult to read also. So most people just like that, just load it into Python and then we'll do it there. But they're nice to know. If you're just using your database as data storage, you have some users in there, you have some transactions. I'm gonna wager that you're not gonna be using it. You might use count once in a while to figure out how many pages do I have of something, but that's really it. Average, sum, min and max, you're rarely gonna use them. But they're nice to know if you're analyzing data. So join. So what join does is it joins data, as the name says. It allows us to take data that's in 2 tables and convert it into one big table. So one thing you will notice right now, if we just like select star from task, like who the heck is working on this task? Alright, user ID 10. Well, who's that? Alright, so I go up here, I then go select star from user where, what's it called, users? Yeah, user. Where ID is equal to 10. I think I can do this and I would only execute that. Okay, so anyone who knows how to pronounce that?
Yes.
Okay.
Yeah, the email.
Okay, so that's basically the same thing.
It's Arabic. Elias.
Yes.
But people don't.
In
Arabic.
Arabic.
In Farsi, also it's like it's
Elias.
But
That would be cool to understand the alphabet, because that's, I think it's pretty cool.
But this is like, why do I need to, all right, now I have this task, now I need to figure out what that user is, and now I need to do it for all 35 tasks. Oh. But what if we had an easier way? What if we had join? Join allows us to say, all right, just take these 2 tables, put them together. But like, how should it put them together? It kind of needs to know, all right, this row matches this row in that other table. So what we say, all right, join the user table. Well, how?
Where user ID equals
No, almost. Almost. What you do is you actually just do user.id is equal to. Is it not like that anymore? It's one of these things I usually auto-generate. Well, time for some goggles. How much are we gonna? Okay, it's still working. So MySQL join lada there. No. Join on. So we do on, not where. So we can say like, all right, join them where the user ID is equal to task.userid. And then you can see, all right, well, that's still just our tasks until we scroll over here. Then we start seeing, all right, so we got the user ID and the ID, and they actually match, which is pretty good. And we also get all that data for the user. So we can actually say that, all right, this was done for Pablo is working on this task, not Pren. So that's what a join does. It tells, all right, how can we mesh this data together without doing an individual query for this? And then the database can figure out how to optimize this so it's actually fast. Another way of doing this.
I don't remember, but I do have a question now about can we use a join statement to create a new table with the data that we just selected?
You can create something called a view.
A view, yes.
What you also can do is you can technically create a table that has all of these columns, and then we'll get to that, but you can do insert into whatever table, values, and then in here you can actually do a select. Join blah 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 blah. And that'll insert the things. But better to use a view.
Now I have a question. We join two tables together by the ID of the users. But here we see that there's user underscore ID and there's ID for the task. What if in the first table we have ID and in the other table also we have ID just as a table name?
And we do in this case.
Huh?
We do in this case. So that's actually a problem. What the database really does, in this case MySQL Workbench hides it for us, but what it actually does is it says, okay, give me the task.id and give me the user.id. So technically, if you look in the data that comes back from the database, it will say user.id and task.id, not just ID and ID. So they will actually have a separate name.
Oh,
because normally they actually have the table name in the name also. And like if you want to go really crazy, they also technically contains the schema in the name. So but
I cannot use like, for example, multiple head name.
No. You can't have no conflict. For example, I can't do this.
No.
And it will literally tell me if I go down here and say, all right, the ID is ambiguous. What did you mean? There's two of them. There are multiple that matches. You have to be more specific. The same thing with here, where I actually said, well, I actually want specifically the user ID and joined with the task ID. Because what you can continue doing is that you can continue joining up with status. So we saw this the status table. So we can join on status.id is equal to task. I think it's just called status ID. Oops. Like that. And then we will also get the status out here. And that again has an ID column. But you can join to get even crazier table, and then you have to be more specific about, because, well, are you joining the thing with something that came from user or something that came from task? And because that matters.
I have a question. I think that's what he's a little confused about the ID, right?
No, I get it, but just like when you're making joins, just like put these two tables together like that. That's it.
Yeah, basic. Well, what it really does is it's the effective equivalent of having two for loops inside each other. So the outer for loop starts running. It runs over task and says for each task in the task table, find, run over all the users, and if it matches one of them, awesome, create a row. And then if it finds a new one, create a row. So what would actually happen here if we had multiple users with the same name? It would actually or the same ID. It would actually, create a row that had the same task twice. Like basically, you can see we have
Now,
As you can see here, we have some of the users twice. For example. So we actually got the user data duplicated in this output. But that's actually sometimes worth it, because for performance reasons, it's sometimes actually faster to get more data than spending time getting less. Because what is faster, downloading the data or figuring out which data to remove? And that depends very much on the situation.
but I have a question regarding the ID, and I think I'm gonna
It's tasking.
because those IDs that you have there, only the ID column, that's the primary key for each table that you joined, right? Now, and I think that's something I want when you let's say when you create, like, that goes into the how you create a database, right? So you have the initial action here, right? Registration, whatever that is, right? So that's the form, the web form. That's going to create something in the database, right? So that's going to create a user. Now that user, that the data that he puts in here, the user is going to have separate tables on the database. One for whatever you want, right? Whatever you want to store, correct? So now let's say the first one is the ID, right? The first column is the ID for each one of them. So what happens over there for the duplicate table, right? The ID, let's say, the first one over there, like something. She created a table, so she has one here with ID 1, one here with ID 1, one here with ID 1, right? And one here with ID 1. That's the first one. The next one that comes, it's going to have ID 2 or 3 or whatever. When you join them together, when you see stuff that's duplicated, that's because this table here, however you create the database, you're still going to select the ID 1 to join them together, right? But if this is a task, when the user creates a new task, the ID here probably a secondary. Would that be a secondary parameter?
No, because what they would have, this is getting into data modeling, which is not part of lesson 1. And we'll be talking about this on lesson 2. How do you actually structure your tables? How did they arrive that it should be called user ID down here? Why did they put that separate from ID? But we're going to be talking about that on lesson 2. Right now we're just focusing on how to actually get data.
Okay.
Not to kill all your fire, but we kind of need to stay a bit focused if we want to finish. And I know that's what?
We have a test.
Exactly. So what joins can do a bit more than just this. So if we just look at the task table again, just completely separate, we see that for some of these tasks, if I recall correctly, there's not a user. It's null. There's nothing here. So look what happens with task 23. Exactly. When I join with the user table. Let's just go order by task.id ascending. 23. Not there. That's because there is no thing user with an ID of null. So it cannot find one that matches. And remember when I said that it does those 2 for loops? Only if it finds one does it create a row. So it just goes through all the user table and didn't find anything, doesn't create a row. Well, what if we want that? What if we wanted to say, I know you can't find a user, so set all of it to null. That's when we can start going into what is called a left or a right join, depending on which direction you're joining in. Left join here, yes. So in this case you see, alright, well 23 is back, and there's a whole lot of no user data at all. It's all null. And that's what we get when we do either a left or a right join. Right is in the other direction, so said we had something on user that was optional and it didn't exist in the task table, it would get a task where all the data was null and we actually had the user information. I actually think we can do it here because we have some users that doesn't have any tasks. Yes, so you can see these two users. They don't have any tasks at all, so it's just all null.
How about if it's an odd number, or if there's 3 tables used?
Then it still follows the same rule. If it tries to do those, basically what it does is it creates this table, and then when I tell it to join again, it takes the table from before, like the table we have here right now, and then joins it with status. So if I do this now, where we say I want it to join on a task status ID, we don't have any of those. Elo. That should be legal. It's apparently not. So we can do it in the other direction. Fun times. So this is a really bad example then. What it will do is it will create that first table, and then it will basically join the new table it created with the status table. So it will just do it individually. Of course, the databases are a lot more advanced than this, and they do it way faster and way smarter using multiple cores and using something called indexes, so it doesn't actually have to do a for loop. It can basically go and say, give me all the users with ID, and then it gets those like this. It doesn't have to actually check every single column or every single row for that. So just like we can do left and right, where we say, all right, if it's a left join, just if there's no user, just set it all to null. We do a right join. If there's no task, just set it to null. We can also do what is called an outer join. Full. Come on. That's not what it's called anymore. The what? What do you say?
I mean, the spelling.
No. Outer is not valid at this position. As you can see. Yes, it's very lovely, very fabulous, very fantastic. We don't hate it at all. It's free. How to do a full auto join in MySQL? Stack Overflow to the help. You can't do that. So it actually says in some of the notes that we need to be looking at this, and we cannot do that. So this is again an example of different database systems being able to do different things. If you're doing MS SQL or Postgres, this will work. But what outer join does is basically a combination of both left and right join, where it says if either is null, just create the other end, whichever is missing. On a use case for that, I have never seen one, to be honest. I can imagine a couple of use cases for left and right joins, but they are mostly for cleaning up data. Or doing things like I want to find all users that doesn't have a task assigned. I can basically just do a left join, or right join. That'll give me a lot of, go away with that. That'll give me like all these null things, and then I can do, all right, where title is null, not equal to null, is null, and then I can basically get the user IDs, so user.id. And like that's one way of doing it, because you remember when we did that count thing, 11 and 12 didn't actually get in there. That's because it's trying to group by a user ID that doesn't exist. And grouping by null doesn't really make sense. So, and there is a whole, if you go over here.
So instead of outer, you will union left and right.
Yes, and basically say, all right, union, and then give me all the things that didn't have data. there are these they are called Venn diagrams that kinda explains what data do you get depending on what you do. So the first one we saw was just join, and that's the same thing as doing an inner join. Full same thing. You just don't need to write inner. If you do a left, well, you get all the data that matches that are in both tables, and that were in the left side. Same thing for right, but in the right side. And then you remember, like, thinking of use cases, getting all the things that doesn't have something. So you can do where the key is null. And then we have outer joins, which, like, they just give us everything. If there's data that's not there, it'll just make up something and call it null. And this is not supported in MySQL, as we just saw. And we can also get all the things that are not in that shared patch by basically checking if both of them are null, or if either or the other is null. So that is SQL joins 101. There are some people that argue if this is the best way to actually explain joins, because this just explains you what data you get. A thing that can happen with joins is that you can get, because what we saw here is that we don't get any more, if you just do an inner join, we don't get any more results than we actually have tasks. Let's just do this. We only get like 35 results, or 33, because there's a couple of them that are null, remember. But what can actually happen with a join is that it can say, for every task, we match every user. So basically, well, we can do the other. Get for every user, give me all the tasks they're not assigned to. So now we got 363 rows out of 30 rows and 12 rows. It suddenly exploded. Venn diagrams doesn't explain this part, but it basically, all right, it duplicates the tasks a lot of times, and then this magnifier is not really easy to work with. It also gives me all the users several times, except the one who's actually working on the task. So a thing that can happen with joins that they do not show you here is that you can get a lot more data than you started out with.
Yeah.
Because like in this case, it multiplied like what, 20 times? No, not 20. 12 times, roughly. Which is about how many users we have. So that makes sense. So watch out for this if you're doing joins. You can get a lot more data back than you expected. Usually, you only get the max of what is in either of the databases, because usually you're saying, just for this thing, just give me this other thing. And that's, in this case, they're nice and easy. They're one-to-one related. Next time, we're going to be working with data structures that have, for example, this class students teachers thing, where we have multiple of them. So in each class, we might have multiple students.
And here the question is, after I make join, can I save the data?
Yeah, you can. You saw how we did that insert into.
Yeah.
Like I showed you once. We're going to be looking more at insert next time. But then you do your data table name. Which columns do you have? You have like task ID, user ID, blah blah blah. Lots of things, values, and then you can actually do a select in here. So select star from task, or you can join it with user on user.id is not equal to task.user ID. I'm not sure why it yells at me, because this is technically. It should be like this, maybe. Differences between database systems are gonna be my death in this course. Alright, again, in some databases this works, in others it apparently doesn't. MySQL, again, doesn't allow this. But you can basically select from other things. What you can actually do, I'm not sure if they're going, we're going to be showing this, but you can actually do a subquery. So we can do, just like doing the join, we can actually implement the join using a where. So we can say, or well, mostly at least, we can say where task or where task dot user ID in select ID from user. This will basically give me all the tasks that have a user assigned. So removing that. And this is something called subqueries. So you see we still get 33 results. So you can, inside one query, execute another query. Just like in JavaScript, you can have loops inside loops. And it'll pretty much just execute that query and then execute the parent query. But you can also, in here, you can actually where, what's a good example? Name like task type. I don't know why you would want to do this. But you're basically saying, all right, give me all the IDs of the users where the user has the same name as the title of the task. Like, this is going to return nothing right now because we don't have any data where that's the case.
It does return, no.
No, it's...
Oh, there's no ID, yeah.
Yeah, it's... I'm actually not sure why it's showing like this. I think it's because it doesn't have a way of showing that there's no results in this view. So it basically returns nothing. But there is nothing here. You can say, look at it down here. 0 rows returned. But if we go in at no, select star from task title, insert into what do we have? User. Let's just set the name values as it should be. Wash clothes. Do that. No. Cannot be null. Of course not. It cannot. foo@bar.com. Hey, we got a user now. So now this should basically work. Unknown column task user to what? This is totally not working like I would expect. What do we get from just doing this? We can't. Lesson of the day, SQL queries, you spend a lot of time fiddling around to get exactly what you want. So join users on user.name is equal to task.title. I think that should work now because I created one. So we get a user that has a name of wash clothes. Why the heck you would want to do that, I don't know.
Just like the person who built this database, he was just very hurried. He just wanted to finish.
Yeah. The thing I don't get is why this does not actually return anything. Because it should actually be doing that. Well, again, I guess this is a difference between multiple database systems.
Can you comment the first line? Because there's an error there on line 4.
So it's basically because I don't have a semicolon here. So if I do this, it'll be, it will not yell at me.
Okay.
Can you do the bottom query again? The select star from task join.
So this one?
Yeah.
I think I know why. It's because these user IDs do not match. So update task set user ID equal to 13, where ID is equal to 1. We're also going to be talking about next time how to fuck up your database, aka by forgetting a where clause on an update. So this updated one row. Save that. Do this. And now we get it back. Yes. I got exactly what I asked for from the database. Just not what I just didn't have the data I expected. So this is like poor man's version of a join. It's also going to be considerably slower if your database is not smart enough to figure out that this is technically still a join. We just don't get all the data from the user table here. So what else do they have here that we need to talk about? Yes, okay, naming convention. That's a quick thing. So in databases, you usually use what is called snake case, which is pretty much thing underscore other thing. What you have worked with in JavaScript is what we call camel case, so like this. In most databases you do this. Another thing you can talk about is, should the table be in plural or singular? And this is religious war. There's no one really correct. I personally prefer plural, but I know some people prefer singular. And you can find books that says different things, and people won't ever agree on this. It's basically the same thing as spaces versus tabs in your code. It doesn't fucking matter, as long as you stay consistent. It's fine between different products to use different ways, just don't within the same product have a table called users, but you call the task table task and not tasks. So just be consistent. Another thing to notice is that it's not case sensitive SQL. I can do this in all uppercase and it's fine. I can write be horrible and do this if I want to, doesn't matter. I'm pretty sure these are also case insensitive. Yes. So casing doesn't matter when you're writing on query. Of course it matters on the values specifically. But for the query itself, casing doesn't matter. What people actually do most of the time is that they write all these blue keywords in uppercase. So they write like this. It sounds like someone is yelling when you're writing SQL. And I get why people do it. It's because it makes it very easy, especially if you don't have syntax highlighting like we have here. It makes it very easy to see what's a keyword versus what's a data. You'll get into some odd cases where this is technically something that exists as part of the data, but everybody creates a table called user. So they can't really reserve that too much. And same thing with name, there's a couple of others. But whatever you want to do, I'm fine. Just be consistent. That's really what it comes back to. If you can't write good code, at least make sure all the code looks alike, so we don't get shocked all the time when we read it. Like that's always what I'm saying. If you're maintaining a horrible code base, you can't improve all of it because it's too big. But you can at least make sure that either if you can't write your new code good, at least make it look like the rest. Because then there will be no additional surprises for me when I'm reading it. Yeah. If you're switching your casing around in this all the time, at least make it look like it's the same person who wrote all the code. And then it tells me to talk about character sets. So you heard of ASCII, right? You heard of UTF-8. Mm-hmm. So let's just go with a good old notepad for a bit here, and then zoom out. Oh, that is completely impossible. We can make it a lot bigger. So, for example, in ASCII, the A character is defined in binary, like I think it's, I don't actually know what it is, but let's just say it's defined like this. So we have 8 bits. the B is defined as the next one up. Or down. Let's just go down now because I was clearly wrong. They're different. What happens, like ASCII only really supports English, so that being A to Z. What happens if I'm a Danish asshole and do this?
They just translate it
Well, what do they translate it into?
like A and O.
You could do that. Oh well, for O in case it would actually be double A.
Yeah.
But what people decided to do is to say, we're just going to invent a new character set. So we're just going to say ASCII only uses these. So we still have another one we can switch around. So if we set this one to 1 and then we have like another 127. And that's fine if you're working with most Western languages like Danish and German and that you can fit it. Then you add in languages like Arabic, which depending on what letters comes after, it changes how the previous letters should look.
Yeah.
Or Unicode, which is also a fun one, or like emojis. So you know how we can have an emoji? I'm not sure if you can actually see that part. No, not like that. So this. So you notice how we have both the male and the female person give face palming. There's not two emojis for this. What there is that there's an emoji that's face palming. Then there's an emoji for the gender. And then there's like this hidden character that tells it to render both of these on top of each other as a third one. And you have all these, you have like these family emojis. There's not like all of these emojis. There's 4 emojis here. And then there's a 5th character you can't see. And depending on what order they're put in, it changes which of these appears. So you can see between these two, it actually switches around whatever the heck. I think that's supposed to be a boy and a girl. It'll switch them around. That's just because the emojis in the characters that this emoji consists of comes in different orders. And that changes how the emoji should look. So, going back to what character sets is, like, you can imagine if we start doing this shit that we'll be running out of 255 bits really quickly. So what UTF decided to say, fuck that, we'll just add another 24 or so. That'll give us a couple more to work with. Now we have 2 billion to work, 4 billion technically, to work with rather than 255, and that'll last a bit longer, even if we keep inventing emojis. That's why you see them, they invent like 10 new emojis per day, and they're not going to be running out for the next several years either way. Or the next several thousand years for that matter. And that's also what allowed them to encode things like Arabic characters together with emojis, together with Danish characters, together with German characters, together with Chinese and Japanese characters. And it'll all fit in the same thing. What happens if I just pick the code, the simple ASCII plus whatever is needed to support Danish, is that if I then suddenly say, meh, this was not actually Danish, this was Chinese, then the data that I get back will be completely rubbish. Because there was my A and O is entirely different things in the Chinese collation, or the Chinese character sets. Because they might still use the same bit code, but it will correspond to different things. The benefit of UTF-8 is that it just works with all of it. All languages in the world at the same time, it'll just work. Don't start figuring out how to calculate based on whatever the bits are, how to render something, because as I just talked about with the emojis, it depends on what comes after. Same thing with Arabic. And Arabic really just uses these hidden characters to do that. They're called, I think they're just called Unicode join characters. So that's why they say here, hint, always use UTF-8 encoding in MySQL. Just don't, there's no need to make a problem out of this. If you can just pick the correct one. The downside of this is, of course, that for each letter we're saving, we're using form, like we're using 32 bits rather than just 8. So it'll take up a bit more space. But I mean, what's worse, to use a bit more space or have your data come out wrong? in some cases.
Based on space.
Yes.
Taking such share.
Yeah, data is cheap.
Yeah.
Like going down in Power or Elgiganten and buying a 4 terabyte hard disk cost like 500 kroners. Like imagine if you had a really rich customer and you spelled his name wrong.
He will be mad.
Bye bye, I'll go to your competitor now. That now cost you 2 million. Like that little hard disk for 500 kroners, that was worth the price. So we could save his name correctly. So use UTF-8. If you're in doubt, just use UTF-8. Like there is no case for not using UTF-8, to be honest, because disk space is so cheap. It's ridiculous. So that's actually all that we had for this time around. Next time we're going to be looking at how to actually stuff data in the database, a bit more advanced than what we just did when we started out. That was basically just, this is how you write queries in this thing. There is homework. As always. The way I would recommend that you do this is that for each of these queries, or for each of these questions, you create a query like you have here, and then you just save it in a text file under this, just indent it or something below. So people can look at the query, because then the people who actually look over your homework can just take the query, stuff it in their MySQL workbench, execute, say that gives the correct result, check, next.
Okay.
You don't need to write out the results here, because we can just execute your code to check. And it's very easy to do with this, because we can just paste it into our...
Okay.
So I think we're going to be looking at the test now.